Hello guys, and welcome back to my channel. So today, like we agreed, we're going to talk about WebSocket servers. And again, this would be a tutorial whereby I would love to give you make you understand the basics as regards to working with WebSockets in Rust, and then of course let you understand like some of the really important components that you would need more or less when it comes to setting this up, and then every other thing would start falling into place after that. I would like us to talk about like the different components. We talk about channels in Rust. We also talk about like how to perform asynchronous tasks and then maybe have, let's say, two different components of your application communicates to each other through a channel, so that maybe when one component completes, say, an asynchronous task, it's also possible for you to like pipe down a message to the other components, so you understand more or less what's going on in your app. So without further ado, I would like us to really jump in and start working. So if you look over here, I would like us to do like a short intro about WebSockets, and then we talk about how we can set this up with Actix Web. We handle WebSocket messages. We're talking about broadcasting, and then we're talking about how you could possibly integrate database while working with WebSockets. So again, this is where we left off from the last time, where we are talking about session and session management, and we also considered how we could do this with Redis. But I think I'm just gonna remove this piece of code in here. We really don't need it anymore, and of course, remove this the middleware session middleware that we try to attach to our web server. And the next thing, of course, I would like us to do is to just jump right in. I will build like a very simple, minimalistic WebSocket handler that allows us to connect and then maybe just send a message, something pretty basic. And then we will go into detail, like every component that has to do with WebSockets and what you need to understand. So with the advent of working with WebSockets, more or less, you have a situation whereby you would love to have um, streaming data. So you would like to have a bidirectional communication, more or less. You wanted to make it possible that you could actually have like say single producer and multiple consumers kind of setting, like a pops up setting, where you would have, say, like a simple chat server where there is like a room, someone writes into the room, and every other person in that room should get a message like right immediately. And so these are some of the, of course, requirements that brought about like the need for WebSockets. So with WebSockets, you get real-time communication, which of course is a crucial part of your application if you're building something like a chat server or a collaborative tool, for example, where you have different users from different parts of the world working on the same document. This can also be achieved with WebSockets. And so basically it provides you a bi-directional communication channel. So between like a client and a server. So and it enables like efficient data transfer and real-time updates. Of course, with Rust, this could be challenging because we'll be dealing with concurrency, we'll be dealing with asynchronous programming, we'll need to manage multiple connections and communications. But those are some of the things we'll touch up in this tutorial. So without further ado, I'm just going to go into our handlers in here, and maybe I create a new folder and I can call this chats, as simple as this. And I would like to, of course, add that in here. So pub mod chats. And oh, my bad. Okay, of course, that's totally fine. And then I can come back in here. I will need to create a mod file, mod.rs. And maybe I can actually write all the code I want here. It's not going to be so much, trust me. Again, like I said, I'll give you like a basic working functionality and then we take up from there. Okay, so I'm just going to call this, of course, it should be an async function. I'm just going to call it WS for WebSockets. So it should take a request, which would be of type HTTP requests, this guy. And it also would need a body, which would be of type web.payload. Come on, web.payload. Okay, and it's just gonna again return something quite simple. So it's gonna return Actix Web. It's gonna return a result. So oh, come on. Oh, seriously. Of course, I added just one here. Sorry, my bad. So it's going to return a result, and within the result, it needs to return an implementation of the responder. And that's really the signature of our function. Is going to be pretty straightforward. Okay, so now I would like to do something quite straightforward. Again, very simple, very basic. Just a handler that allows users to communicate, write a message, and we probably just console log it. That's fine, and then we get into detail. That's what I want us to do. So I would like to get a response. I would like to get a session. Come on, if I can type today, and I would like to get a message stream. Come on. And of course, this would come from Actix. I need to Actix WebSocket, and then this should come from handle function, and then in here we'll pass our request and response. I want our body more or less, and then for now we're just going to handle the error like this. I'll expand this out so we have more room, or maybe I actually just collapse this. Let's see what's expected. Okay, it's really about a response type. That's totally fine. So when we have this, what I would like us to do is simply like spawn up a task more or less within this handler, because it's going to like infinitely establish a connection between the client and the server to allow bidirectional communication. So I can say Actix Web RT, and I need to spawn. And within here, I simply need to pass an async function. So it's going to be an async move. And in here, I will simply just match the message that we are getting back from the user. So I can simply say here, of course, again, like I said, it's going to be an infinite loop. So I can say why let sum, because I want to handle the message that we are getting from the user. So if it is okay, if we have the message actually, of course, why this will come from a message stream, say dot next. So if we have a message, we want to constantly, of course, process this message that awaits. And actually, I should make this mutable. I think should be mutable, and maybe I even make the session mutable for now. And then I say if I actually need it as mutable or not. So I need to handle, of course, our two scenarios in a way. So I match. I would like to match the message. And in here, I will need to handle the two. For now, I would just take care of maybe two scenarios that could happen from messages, and that would be if it is a ping, and then the next thing would be just message itself. So Actix message. So this has to be, I want to handle ping first. So again, this could be, I'm just going to assume this would be bytes. So if this is the case, I'm simply going to do something like if session dot pong, and then of course I want to pass a reference to this bytes, and again we await. If there is an error in doing this, I'm simply just going to return back. That's really what I want to do here. And then of course, if that's not the case, if our message is I'm interested in a text, if our message is a text, so of course this is the interesting part for us now, but I'm just going to keep it simple. I'm just print this more or less, and I can say something like we have received the message, and in here I'm just going to pass the message. And other than this, of course, I think I have to of course print this out this way. Other than this, of course, for now I'm just going to break. I don't care about the rest. Or maybe just to make this easier for us so we actually see what we are doing. Down here, I can simply just return this response. I want all this error to go away actually. Okay, so now this is gone. And now so here we are spinning off a new task more or less that's going to handle our like message handling, establishing this bidirectional communication between like our front end and our back end. And it's going to do this, of course, on a new on the current thread, more or less, but a completely new task for this new client. And so we are getting some error here. Okay, of course, I need to pass this by reference, and that should be fine. And in the end, what I would like to do down here is simply to just close the connection. Of course, let me see. So this would be session.close, not clone actually. Wanna close, and I'm not giving any reason for now. And again, it's an async task, so I'm just gonna await it. And of course, I need to close this off, and then this should give us return an error actually, I think. Yes, so, and for now, I'm just gonna throw the error away. And that's really what we want. So basically what we're doing right here is we allow the establishment of this connection between the front end and the back end, the client and the server, and then we spun up a new task on a current thread, and then we constantly, like you see here, this while is actually an infinite loop where we constantly listen for messages. And for now, we are only interested into two scenarios, one of them being just a pong and one is the actual test. We simply, again, just log this on the console, and then that's it. Okay, so what we want to do now is to go back to main and actually use our chat server. Actually, we can just come down in here and then say route. Come on, routes, and I want this to be, it's gonna be quite simple. It's /ws, and then here we'll do again similar to what we had under there. So it's be a get dot to, and then here would go to handlers. I'll go to chat and we go to command. Let's see. So we simply go to our WebSocket handler and we got an error and it says it's a private function. And that's again totally fine. So we can come back in here and we'll make this, of course, a public function like this, and then our error should go away. And now we can simply open our terminal. And then we say again, cargo watch. Do we need to do this? Okay, let me do it. It's totally fine. And then we build our application one more time. And what we can quickly do is to go to the browser. Let's give it some time. Okay, now it's up. What we can simply do is to maybe I make this smaller screen. And then because I would like to open a new tab down here. Come on. Let me see. So I have here a new tab, and I would put this side by side to our browser. I hope you can still see this. So I expand this a little bit more, so we have more room. Sorry. And I'd like to go to WebSocket King. That is a web page called WebSocket King. I like to use this to basically just test things out. So now I create a new connection. Can I collapse this part? I don't think so. Anyways, so now we go to WS. Of course, the protocol is WebSocket. And then we go to localhost 8080 and we go to /WS and we connect. And we could not connect. So let me see what error we have. I can, or maybe I can simply just copy this. No, of course, without the protocol, just until this part. I'm coming here, paste this and see. Authorization header wasn't, of course, we are not taking care of this right now in our app, but if you remember, we have here our middleware that handles our validation for us. So I can simply comment this out, and let's give that a couple of seconds to rebuild one more time. And now I can, okay, now it's up. Now I can come back in here and visit this. And now you see I don't get the error anymore. I get a different error, but then I can come in back in here, clear this up and connect. And now you see we have successfully established a connection with our server. And to test things out to see if we are actually handling this message as it comes in here, I can maybe come in here and say, hello from client. Okay, of course, we have disconnected because our server had auto reload. So we connect it back again, and then we send this message. And now if you look down here, you would see that we actually get the message to the server. Of course, for now, we're not handling it. Like I said, quite simple, straightforward server, just to show you how things work. And so far, everything looks good. So I'm just going to close this. We don't need it anymore. We can come back in here. I'm just probably going to shut down the server. And now I'd like to us to talk about what we actually really need to work on our WebSocket server, like the different components you would actually need to work on if you're working on an enterprise application, let's say at your workplace, what you would really need to do to have like a production ready, like a great WebSocket server. Let's just have that conversation right now. So the first thing I would like us to look at would be channels. So you can think of channels as like a really, really fundamental concept when it comes to concurrency programming. And of course, in Rust, this is a really, really important topic because this is really the basics of what it means to enable communication like between threads or asynchronous tasks. So you can really think of them as conduits. That's like you could have several of them within your application that allows communication from one part of your app to the other within the same ecosystem. So of course it's an internal process of communication more or less for sending and receiving messages, of course ensuring thread safety and preventing like data races. So, but in the concept of WebSockets, for example, we can actually use them to facilitate communication between WebSocket server and the application logic. So things like when a new WebSocket connection is established, we need to have a channel, for example, that can be used to create and receive messages between that communication, like the connection handler and the application's business logic. And of course, not just in Rust, this is also like a thing in most programming languages, like Go, for example. And I can maybe say from experience that with Go, it's a lot more easier to actually do concurrent programming. And but there are like I've seen like lots of probably complex applications where people have had like tens or even let's say 40, 30, 50, even hundreds, for example, of different channels within the application. Again, depending on the how complex the application is. So allowing like smooth communications within the app. Um, and I can also maybe show you a simple example of I can bring this over here so you can see it. A simple example of an app that I'm working on more or less. And I try to profile the application right now just to show you some things. Of course, these other things like allocations doesn't really matter, but if you look over here, you would see like Go routines. And if you actually look through them, you would actually see these are actual Go routines that are available within the app, and you can actually think of them more or less as in this concept as channels. So they're like different portals, different conduits within the app that allows me to send messages from one app to the other, let's say after the execution of some asynchronous task. And but again, this is for Go, but let's focus on Rust today. So I would like us to look at a very simple example. Maybe what I can, I'm probably gonna do everything in here because maybe I just comment this out anymore. But again, remember we have our middleware here, so anything here would of course need to be authenticated. Anyways, I'm just gonna comment this out, like I said, because I want us to focus on of course talking about concurrency in Go, in Rust, sorry, not Go. Anyways, so what I would like to do now, maybe I'll of course comment this out, don't need it anymore. So but what I would like to do now is we don't have any main function, so that's why we're getting this error. Anyways, so when it comes to channels with Go, sorry, with Rust, I would like us of course to look at the Tokyo package, and I'm already guessing you're familiar with the Tokyo crate. So but the important thing is of course with Tokyo, there are like 3 4 basic primitives that allows you to do like basic creation management of channels, of course facilitating communications within your app. So there's of course MSPC, which probably is the most popular, where it offers like multi-producer and single consumer channel. You have one shot, you have broadcast, and you have watch. And we're going to look a little bit at some of them. So I can actually just maybe come in here and maybe can comment this out and come down here. I can have my phone off. This is not Go Tony. So I have my main function. Oh, come on. I have my main function like this. And now, of course, the error has gone away. And anyways, here I can actually, maybe before this, I can actually come over here and then bring in, let me use this from the standard library first. I'm going to go to standard and I go to sync and I go to MSPC. And so I can actually just come in here and use this to create a channel. So I can say create, let me leave a comment here. I say, come on, create a channel. And in here, it's quite pretty straightforward. I would like to, of course, I need a producer and of course a consumer. So I can call this, most times the convention is actually to name them TXRS, but it doesn't really matter. So I can say MPSC, and I can say channel, and it's going to be I can also actually annotate this more or less. So I can annotate it more or less to, of course, indicate the type I would like to have in here. So it's going to be string. And so basically now we have our sender and our receiver, as you can see here, and what's actually being transferred within this channel would be, of course, of type string. Again, this can be of any type, doesn't really matter. We can actually come over here and say I have a struct, and I can call this message, for example, and it doesn't really matter. You can actually even make it like this, doesn't matter. And then this can also be the kind of message we share between our channels. As you can see, it changes. But anyways, I'm just gonna remove this for now just to show you that that's actually possible. So nope. So for now, we want to have a string channel. So now we have again like a sender and a receiver. And then what we can actually do is, just to show you, I can maybe spawn a new thread down here. And of course, I need to bring in the thread module, of course, from the standard library. I can simply go to thread. And of course, I can combine these two imports, but let's stay on thread on point here. So I can say thread and spawn. And of course, I'm just going to add an anonymous function in here. So it's going to be a move. And down here, what I simply want you to do is basically just send messages into this channel. So I can simply say it's pretty straightforward. You can actually call the send function, and then you provide the payload. Of course, it has to be a string. So now we can simply set like string dot from. I can say hello like this, and of course there's probably going to be an error, but for now I'm just going to do unwrap. So this is just going to send one message and then into the channel, and of course I can also come down here and add another one, and I say world, for example. So it's going to be hello world. And then in here, of course, it's just going to write into this channel without actually us having what to consume this message. So in here, I can handle the messages. I can say handle messages that are coming from the channel, and I can now say, listen, I can say MSG, for example, in RX. So this is actually how we listen to our receiver and more or less consume all the messages that are coming from our receiver. So in here, again, I can simply just do a print line, and we'll say something like message from channel. So this is just going to be our message. And that's really all we need really to create and communicate using the channel. So I can run this, say cargo run. And you can see in our terminal, this would write those messages into the channel, and then our receiver will actually receive those messages in that order. It's really this is the basics of actually working with channels in Rust. So again, in case you don't know, this MPSC module actually means multiple producer, single consumer. So you can also see here. So it's actually like a FIFO queue, more or less. So first in, first out. That's actually what that means. And this is the basics of using this. So again, so you can actually use multiple threads or tasks, which can actually send messages into the channel, but then you can only in our own case, we can actually or have like a single consumer more or less. So again, you can think of scenarios whereby you need multiple writers into a channel and then just one consumer. Again, this is something we can actually use with our connection logic. So when a user or a new client connects to our WebSockets, we can actually have them write a message into a channel called whatever, maybe just for handling our connections, and then there would be one single consumer that's going to handle the connection of all the clients just to keep track of what's going on. That's one use case. But of course, using the MPSC module from the standard library also does the job. But what I would like us to do now is to actually do the same, but now I would like us to switch to Tokyo. So if you don't know already, but I guess you do, Tokyo is more or less a popular asynchronous runtime for Rust. So with it comes like a set of tools and abstractions for building efficient and scalable network applications. So like when it comes to WebSockets in Rust, like we're talking about, we would encounter like of Tokyo's MPSC and one-shot channels. Again, this is also another channel that I would like to show you. So the MPSC module in Rust is in Tokyo is actually similar to the one in the standard Rust package, but it is really designed for asynchronous programming. So again, it allows multiple asynchronous tasks to send messages to a single receiver, and then it of course enables efficient communication between different parts of your of our application. So for to work with that, I'm really just going to come in here and get rid of this, and now I would need this to come from Tokyo sync. Again, MPSC like this. Oh, sorry, my bad. And now I can actually get rid of this. We don't need this anymore. And then if you look here, of course, we now get some error because it's implemented quite differently. Of course, but the difference here also, as you can see, is that this needs to be like a buffered channel. So if you see here, it's expecting an argument of type usize, which is missing. So if we, for example, add say 100 here, so this of course gives us back a buffered channel. It has a size, it has a capacity, which is 100. And so for now, also, we actually don't need to do thread.spawn. So we can simply actually do Tokyo spawn. And now, of course, this also needs to be an async move. And of course, to actually have this async function, again, I'm going to come back into our main function and actually make this a Tokyo runtime. So Tokyo main. And so again, now of course the main function itself has to be async. So now our function is async, and now we need to handle again like what we did initially. And I would like to maybe make our receiver mutable. And now I can actually get rid of this. So that in here I can maybe do something like while let sum. So I would of course want to constantly receive more or less the messages coming in from our channel. So we can say rx.receive, sorry, dot await. And so while this is the case, I would like us to simply just print line, and then here I'm just gonna print maybe again something like what we had here. So again, I'll copy this part and put it in here. And then what I can actually now do down here is like what I cut from, oh, sorry, I think I overrode that anyways. So now I can say tx.send, come on, seriously, tx.send, again, I do my string from, and maybe here I'm gonna say hello world. And now, of course, I can await this and maybe now unwrap. Of course, oof. This is not required here anymore. And anyways, I can now copy this again and then bring it down here and say, I don't know, have a lovely day, whatever, doesn't really matter. And then we run our program one more time. And then, of course, we get the same behavior. The only difference now, of course, we've switched to the Tokyo runtime because, again, this offers us much flexibility as it pertains to asynchronous programming. Okay, now, so we've looked at MPSC from Tokyo runtime, and now I would like us to look at one shot. So with one shot, it works a little bit differently. So it is, you can think of it as a specialized channel when it's that can be like used to send a one-time value between asynchronous tasks. So you can imagine that you have a scenario whereby you need to send a response or a result back to a caller after completing an asynchronous operation. So that's one of the use cases where I would actually find it useful to use the one-shot channel to enable communication between your app. Again, we're going to proceed like we did before. There is not really going to be much changing. So only that here would now have one shot. And of course, like we said, it's going to send a one-off message. So there is no need more or less for us to um, have like a buffer, like the size of the buffer here. Anyways, so maybe what I can actually do is to maybe to make it a little bit interesting, I can have a function here. Of course, it has to be an async function. I'll say handle msg, and it's just gonna return a string. So let's just assume this is the asynchronous task that we would like to more or less be performed in the background, so that when it is done, we send a one-off message back to the caller. This is one thing we can actually do. So here I can say string dot from, and I can say maybe completed async task. So this will be the message we would like to call from our application. So in here now, I can actually have, of course, it's still going to be an async move, but the only thing I would probably do here is now to simply call this function. I can say let's response. Response would be coming from our handle message function. It's going to give us a string back. Again, it's, as you can see over here, it's going to be a future. So we need to await it to get our string back. And now once we have our string, what we can simply do, of course, we don't need this anymore. Just going to get rid of this. And now we can simply send this into our channel. So now I can say response, and maybe of course handle any possible error that might arise from this. And now in here, what I can actually do, again, now I don't need to send this message like this anymore. So now down here I can say let's response. Response would be coming from our receiver, and then we we unwrap, and we await, and then of course unwrap to handle our error. Again, we are not really handling our error that as we should, but that's also fine for now. Again, we try to print our message to actually see what's coming on. Say, we'll say the response is something like this, and then in here we'll put our response like this. And again, actually, I didn't need to change anything here, so I'm just going to leave this as this is not going to be mutable. And now I run this operation one more time, and now we can of course see this happen. Let's give that a couple of seconds to complete, and now you see we actually get our response back. So this is like using the one-shot channel again for one-off calls to some asynchronous background job in your app, and then that needs to simply complete and then send back a one-off response to you, and then that's it. Okay, and the last kind of channel I would like to show you, of course, would be broadcast. Again, it's pretty straightforward. So I'm just going to again change this to broadcast, and we have that imported. And so again, to create a channel, I'm just again going to do broadcast, and then we have a channel. And of course, now we don't need to actually create it this way. Of course, we need to I think yes, we can create it this way, but it needs a buffer, so I'm just probably gonna make this 2. And again, we have our channel right here, as you can see. Now, what I would like us to do again, this whole thing actually much similar. Again, the only difference is like what you can do within the functionalities they offer you in the end. So what I would like us to do would be, I'm just going to get rid of all of this for now. This is getting so cluttered, so I'm going to get rid of this as well. Maybe what I can actually do is copy. Again, this is actually, I'm just going to get rid of this because it's really not entirely true. But I'm just gonna duplicate this. And again, if you look here, for example, it also has the same functionality more or less. But again, with broadcast now we have the option to actually not just have for example just we have this functionality now that we have like the option to deal with like multi-producer, multi-consumer kind of scenario, so like a broadcast kind of thing. But what we can actually do here is we already have one receiver. I would like to create a new receiver, and again it's also going to be all we need to do actually is more or less to subscribe to what we have already. So I can say let's mutable, so I have a receiver 2, and what this receiver 2 is simply going to do is subscribe to our sender here. And that's really all we have to do to get a new receiver. Again, if we need a third one, I can already imagine, we just simply throw in a third one. And so in here, what I would like us to do again now would simply be to just write a message. So I'll do a print line in here, and I would like us to look at the message that's coming in here. So I can say results. I can give it an ID of 1, for example. And now I provide, of course, what needs to come in here. So I can say RX. And maybe I actually give this an ID of 1 so we can differentiate. So I can now say receiver 1 dot receive. Okay, and of course it's an async function. I await, and maybe I just unwrap as a way of handling the error. And this will help us print the message coming in here. Again, I'm just probably going to duplicate this. Again, we said the size is going to be 2 because it's buffered. So I'm just going to leave it like this. And I'm just going to again copy this here, come back into this new spawn and paste it. So, but now I will receive from receiver 2. So I'll change all of this to 2, and again update the IDs to reflect with the messages that are coming in here. And I think this also needs to be mutable, of course. And then in here, now I need to send the messages. So I can say sender.send, and here maybe I send 120, for example, and I unwrap to handle the error. And then maybe I can, of course, do this twice because we said this is buffered and the size is 2. So now I have 2, but the only difference now, of course, is that what is the error? Oh, we are still making this a string, so I can maybe make it I32 example, and this should be fine. Oh, not 232 20, but I32. Okay, I'm just going to increase the size here. Maybe if it doesn't even matter, I'm just going to make it 100, and then I run this one more time. And then what happened? Yes, of course. What you see here, of course, is that we send our messages twice, but the messages gets through to all our subscribers. So subscriber 1, of course, gets both, and 2 gets both as well. So like these are some of the things I would like to talk to you about channels, because this would really prove useful. Again, like just imagine some of the instances and the scenarios I've given you already, where this could actually come handy when you're working with a WebSocket server in Rust, and then you can begin to appreciate what you can do, like the complex, more interesting, advanced stuff you can do with channels as it pertains to asynchronous programming and real-time communication, of course, within the Rust ecosystem. Anyways, of course, the next thing I would like to talk to you about would be futures. This is also like a really great important topic. So I'm just gonna get rid of all of this. We don't need this anymore. So I'm just gonna clean this up a little bit, and maybe I'll bring back our code. I uncomment this out, so we have this in here, and I think nothing. Okay, now everything looks okay as it were before. And so now we are good to go again. So, but like I said, I want to talk to you a little bit about features. This is really quite essential, of course, if you're doing async programming in Rust. So they are a way to represent asynchronous computations that may complete at some point in the future. So they allow us to write like non-blocking code that can efficiently utilize system resources, like while waiting for IO operations or other long-running tasks to complete. So the async, which you're familiar with the async await syntax in Rust, makes it a lot easier. Like it gives us this ergonomic way to work with features. It makes asynchronous code easier to read and write and actually like understand more or less. And it's also important that we understand on in the background what this actually means, because again this is really quite important if we are dealing with streaming data. Again, like if we're working with WebSockets and want to set up a WebSocket server, it's really important for us to understand how this works in total so we can understand how to handle streaming data as they come in. Yeah, so but what I can actually do is for those, I would leave some important articles that I think you would really prove useful for you to really understand how futures works with Rust, because I think it would really take us like the whole day more or less to actually try to talk about this in this tutorial. But of course, again, I want to bring it to your attention that this is really, really important. And then I will also provide some important links again, like I said, so you can read up on certain things, because again, this is really important to synchronize primitives, for example, so allowing you to coordinate access also to shared resources in an asynchronous mode. So if you understand this very well, it would mitigate a lot of problems for you if you start building your application. It would help you, of course, handle more maturely, like and prevent things like rest conditions in scenarios whereby you have like shared resources within your asynchronous application that has a lot of async tasks that need to run in the background. Anyways, that's really what I wanted to talk to you about. I'll provide you the detailed links, very, very simple, short, and detailed documentation so you can look through to understand how features works in general. And again, like I promised you, in the end, we would, as part of the projects we would handle down here, I would also like to show you like a really working functional chat server. So maybe I'm just going to copy this also. Maybe that would be the first thing I actually do in here. So I can simply call it is a it's gonna be really great. So I can just call it production grade chat server. So this probably is gonna be the first thing we'll work on. We'll take all of this together, and then when we do this, I'll again take out some time to talk to you a little bit about futures. Hopefully, then would to be an easier conversation for us to have, because by then I'm guessing you would already have been able to read through the articles and understand how things works. And anyways, of course, the last thing here would be simply to write into our database. So in the integration actually means just how we actually persist the data. Of course, if we have this in memory, if the data crashes, so we actually stop the server. If we restart it next time, our data would be lost. But again, when we are done with this, you would also understand, of course, with async programming that this is one of the things you can actually delegate to, like you can actually spawn off a completely different task that have this running on the background. So if a new message comes in, you can simply broadcast this. Everybody needs to get this message, and then you maybe spawn up an async task that's going to then write this to your database, and that's really all there is to it. Again, we initialize the first time, just read the data, then just show this, and of course the magic continues. New messages come in, broadcast them, whoever needs to get them would have them, and then in the end, you dispatch of an async task that would then persist this in the database. And it's really as simple as that, guys. Anyways, I would like us to draw the curtains here for this tutorials. We still have a lot of things that we would want to talk about. So please, of course, stay tuned, and I will make sure that I bring you all of this in due time, as detailed as possible, so you can of course find it useful. And of course, if you are new to our channel, please don't forget to go ahead and subscribe, turn on the notification bell, and you would always be notified each time we have a new content. Anyways, guys, that would be all for now, and until we see each other next time, have a lovely day. Bye.